Today we want to spend some time talking about the inverse of the sine and cosine functions. Hopefully we can get to the point of saying this is what the graph of the inverse looks like. This is what it means to evaluate the inverse, and we can successfully evaluate that inverse and understand what it is we're achieving from that inverse function. Because we're talking about an inverse function, we need to remind ourselves what it means to have the inverse of a function. And we did this way back in the first semester, so it's been a few months. But we were all here, because I remember talking about it. I remember you telling me some things about it. So do you remember anything about inverse functions? Ooh. That's good. That dreaded silence. Alright, let's play a little jog the memory. If we're talking about inverses, if I take some number and add 5 to it, what would be the inverse of that particular operation? Subtract 5? Addition, subtraction are somewhat inverse operations. They do something and then they undo that something. If, on the other hand, you got something for me?
Yeah.
What you got?
They're reflected over the y equals x axis.
Oh, excellent. So the graphs reflect across y equals x.
D of f, or d of the function of x is equal to r of g of x.
Okay. That's great symbols. I do know what that means, but if we're going to say those symbols, let's provide some more definition to what does D in this case mean. Now, I have to tell you that next year in calculus, D is going to be something totally different. When you say D of something, you might have something totally different thought about, so we don't want to confuse people. When we're talking about the D in this case, what are we discussing?
Domain.
Yes, the domain of the starting function becomes the range of the inverse function, and so therefore the range of the starting function becomes the domain of the original. That's really kind of important. So they trade. That's part of that reflection across y equals x. So that means that probably when you think about the domain of this particular function right here, right now, that sine function. Now, when I had you draw and I said, please use this, guys, this is a domain. I restricted your domain. That's why we talked about starting in a dot, ending in a dot. In general, for any particular trig function, like the sine function, do we know what the general domain is without any restrictions at all? Give me a guess. Did we talk about how this thing could keep going in that way? And how about, what was it?
XCR. X equals all
So,
numbers.
all real numbers. We can use the whole number line in both directions for really a domain of this function. What about the range of this function? We're stuck right here, aren't we? Between 1 and -1. That's it. Good. So that implies for my inverse, what is the domain implied for my inverse? So yeah, we're going to just say, actually it's going to be right in here, -1 to 1, because negative pi, or pi over 2 is 1.57. So we're really going to narrow this thing down a lot in terms of what our domain is for the inverse function. What about the range? All real numbers? So if I correctly draw an inverse function, I will get a function from it. Is that correct? So let's see what it might look like if I draw the inverse function. Is that a function? Think about it, yes or no. Don't say it out loud. Think about it, yes or no. Is that a function in blue? How many think, yes, it is a function that's in blue? How many think, no, it's not? Why not? Oh. Whoops. So mathematically, what do we have to do? As good mathematicians, when something doesn't do what we want it to do, what do we end up doing as mathematicians? We start changing the rules a little bit. And we come up with ways to make exceptions. So we're going to do the same thing here. Good mathematicians. So we're going to try something here. Get some things in the way. So I'm going to start using a block here. By the way, I need to change the property of the block. I want a solid fill, and I don't want it to be red. That close down some things. Well, come on, you. Nope. So I want to move this thing around. So I cover up a portion of this function. And we got to have a couple of rules in place. Remember, I must be able to choose all those range numbers. So whenever I block something off, I need to be able to be sure that I've used from -1 all the way up through +1. The second thing that we want to be able to do is we'd like to be able to have the curve connected. I don't want a little piece here, a little piece here, or a little piece. I want it together for my inverse. So we got to pick something that's together. We got to pick something that does all positives and all -1s in terms of our values vertically. And it's kind of nice if it's around 0, 0. Is there a location that we can imagine here that's going to meet some of those requirements?
What are we doing with the block?
I'm covering up part of the curve. I'm saying, okay, if I hide the curve, like, if I do this, if I hide the curve here, and hide the curve here, and I say I'm only going to work from here to here, that's going to be my new domain. I just want you to be able to visually see it. We can move it back and forth instead of me just erasing a bunch of stuff. I want you to be able to see some things.
Let's go one for then -9.
There you go. So you want, you didn't say that. Did you say -pi to pi?
Yeah, that would have been.
You want back here. You want there to there. -pi to pi. But what is our nice little test that we use to determine if we could actually take the inverse of the function presented? Remember what it was called? Say it louder.
Horizontal line test?
Yeah, remember when we actually see the equation drawn, we draw the vertical line test, and the blue one didn't pass that. But if we're going to check it to see if it works, we draw a horizontal line through here. We draw a horizontal line through here. Do I touch the curve only once? No. When we touch the curve only once from the horizontal line, we call that function 1 to 1. When that happens, we can say we can find the inverse of the function. Now, the second question I have for you is, are we getting closer? Well, if you look, before, I touch it a bunch of times. So doing this, we're closer. So what should we do with these blocks? Cover up more or less, or what should we do?
Cover up one and make it, or cover up the exact place where it touches. Yeah.
So come to here, and come to here. Look at that for a minute. Do I pass the horizontal line test with this information? Okay. Do you know, based on our graph, where this x value is located?
Yes.
What is that location? Good. What's this location? Okay, do you understand that? So now we're going to say, we're going to go to a new slide, but we're going to say that we want to have only -pi/2 to +pi/2 being our domain. So let's do this. So if I look at that domain set of values only, I'll draw that picture in a second. Do we know the range set of values for that? picture. What was going this way? Yeah. Okay, so that's going to be kind of the region we work from. So let's look at that.